Kangaroo gastrocnemius exhibits baseline pennant fiber architecture, with fast-twitch glycolytic fibers predominant. Sarcomers maintain resting length via tightened filaments, stabilizing myosinactin overlap. Mitochondria sustain low ATP hydrolysis through phosphocreatine shuttles. Achilles tendon stores elastic strain energy as collagen fibers align under minimal preload. Jump initiation triggers motor neuron depolarization, propagating action potentials via synaptic transmission at neuromuscular junctions. Voltascated Na channels open, inducing Ca² influx through dihydropyridine receptors coupling to ryanodine receptors. C binds troponancy, exposing myosin binding sites on actin. Cum. Sarcomers shorten via actin-myosin crossbridge cycling powered by ATP hydrolysis. Q-strixim contract eccentrically, stretching tendon collagen. Q-strict force generation reaches maximum via synchronized crossbridge attachment across parallel fibers. Amplifying tension through pennantiometry. Elastic recoil from tendon fascicles returns stored energy, enhancing stretch-shortening cycle efficiency. Fatigue threshold emerges from lactate accumulation inhibiting phosphofructicanase. Kakamas, depleting glycogen via anaerobic glycolysis. Exceeds equine soleus capacity due to higher fast-twitch density. Acropodod lineage evolves elongated calcaneus and fused tarsals by Miocene, optimizing gastrocnemius leverage. Fiber, hypertrophy, and tendon hypertrophy enhance elastic energy storage over 20 million years.